Let's go into a little more depth talking about electric lighting simulation in Climate Studio. Here's a basic floor plan that we used to illustrate a basic simulation workflow. We created three rooms and that had different target lux values. We created work planes in those rooms and added luminaires in each room to try to, and we adjusted these as needed to deliver the lux values we were looking for. Let's now look at this in more detail and just focus on one light, or one room. And let's edit this light. First thing, oops, wrong. Or this, I'm sorry, this luminaire. Often a light is a bulb, a fixture or luminaire is a series or an assembly, and that's what you're purchasing. So if we look in the Climate Studio lighting library, we'll see that it's pretty sparse. There's plenty in here to learn and play around with, and that's all we may need in this class. But if you're trying to get into more detail, for example, designing lighting for a studio project, you may want more nuance than this, and that's easy to do, or you can do it by accessing more of these lighting files. And these, as is typical in our industry, um, are generated by a standard. That standard is, in this case, created by the Illuminating Engineering Society, so that's IES. So manufacturers produce IES files of their lighting components that they're selling. And IES files are available, for example, in Revit. You can download these and bring them directly into Revit. Here's a page from Autodesk with a good description. IES file is a text file that describes the intensity of a light source at points on a spherical grid. So it's just essentially saying how much light is this fixture putting out and how is it dispersing it. So here's our spherical grid. This is a horizontal section through it. Here's a vertical section, and here's the disbursement we're talking about. And we've talked about that, so the luminous output is lumens coming off the bulb in all directions. The luminous intensity is the luminous flux, and that's in candela. That means in a certain direction. So we've got this is the luminous flux going in a certain direction here. Oh, that's a graphic of it. And so we can then look for lights that we think, let's see, where's my file? Meet our needs, or we can experiment. And so there's different places you can find. This is just a website that has a nice browsable set of IES files. But before we download any of these, let's go back and just close that and run the simulation with this light to remind us what's going on or how this works. So I'm set up. I've got my work plane. I've got a light in there. I'm going to hit go. And we'll see that we're already getting a result. One thing to remember always, the colors are nice and they're very useful, but we're controlling those. I'm going to go ahead and stop this because this isn't changing. So it's basically complete. Remember, so this is set on a range of 0 to 500. If I made it 1,000, it would look like there's very little light. If I make it 50, it's going to be a ton of light. So what we set this on is arbitrary, and it's a decision we're making based on the amount of light that we want to produce and the graphic look that we want to have. So the point being is that this is the colors aren't really that important, though they're important to our graphics layout, but they don't tell us anything about the actual output of the light. We're getting a mean of 31 lux, which is well below what we're hoping for, 100 to 300. So let's edit this light. We have a 11 watt 6-inch circular downlight. So if I come in and, well, let's just go for a 42 watt 6-inch circular downlight. We can see now we have a much higher lumens in candela. It's going to obviously change this quite a bit. And by the way, it's always going to be the case. These go very quickly, but also we don't really need to run the complete thing. This is already not changing. It's because we're doing a point in time illuminance model, and there is no sun. Therefore, it's at night. Again, we're at night, so the the illumination level is going to be constant. So it should just be we run it really quickly and we get the results we want. Anyway, so that's my, here we're at 100 for a mean, 26 median, but the means we're interested in, the average, and so we're at the bottom end of the range of what we were looking for. Um, okay, so great. That's the workflow. But now let's change this light. Let's go back to this website. Where was it? Here. And pick some different lights. I'm going to start with, this is a pretty strong, let's pick this strong down light. I'm going to download the IES file, come back to my model, edit the luminaire, browse for that file. I think I'll rename it, and I'm just going to name it test 1. And I am now going to run, or I'm sorry, going to select it. And so we can see already that this graphic of the luminous flux is accurate to what we're seeing in our model. So it seems to be, or in our graphic from the IES file. Let's run it. And so relative to the previous light, it's much more directional, which matches the graphic here. So it's working, is the point. And we could now, if we wanted more or less lux with this, we could either go find another light, or even if we kind of wanted to just keep this light, but just simulate it with a higher power, we can do that by just changing the power multiplier. And now we have a much stronger light with the same uh, dispersal pattern. So let's just try a couple more to make sure seems to be working. Let's pick some other ones that are very different. Um, this is sort of like looks like a double floodlight in a direction, directional. Um, in other words, it's not going down toward the floor, is the way I'm interpreting that. Let's just see if that's true. I'm going to download it. By the way, there's this nice graphic here showing you you can scroll around to see the dispersal of the light on the floor. Again, a simulation before we simulate. Let me go back to my model, edit my light, browse for that file. I'm going to change this one to test 2. Oops, I'm not going to. Let me change it. Now we can see that was what I was thinking. It's a light that's directional toward the wall. So we probably would set this, we may not set it in the middle of the room. Um, but let's just run this and see what we get. As we would expect, we get a different pattern. I'm actually going to stop this and change. It's a much brighter light. So I'm changing the range. Interesting. I interpret that to be directional in a slightly differently than the way it's expressing on the floor. So I'd have to mess around with this light and see exactly how it works. But it does seem to me clear that is functioning in terms of this model. And that's all I'm trying to determine here. So let's try one more. How about an uplight? So this should be directing light to the ceiling if this is, I mean, based on this graphic. Come back and edit my light. Just to be consistent, let's make this test 3. And right, so this is pointing toward the ceiling. I think I might have to move this down for this to work, because, we're not even, I don't think it needs some space. So let's try it. Because I don't know, I'm just downloading this light for the first time. Right, you see, so we have zero lux on the work surface. It's not because this isn't working, it's because I don't have the light placed correctly. So let me stop that and move this light down. Just, I don't even know how far I need to move it down. Let's say to there and run it now. And so we are getting some light on the floor. Now, of course, it's not a lot, because it's not, that's the point of this light, is it's reflecting off the ceiling. And so if we went and changed the ceiling material, let's try that. Trying to think what would be the most, let's see if I just add something that's white, bright white. Let's try that. So now I've changed the ceiling material to be something different. It should change this somewhat. So we're at, we can compare them easily. I actually lowered it. So I guess the concrete was more reflective than the white paint that I chose. But the point is we did change it, right? So you can see this is 108 for the new and 120 for the old, right beneath. So there's a different reflectance for the ceiling, between those two material choices. Anyway, so we've established that we can very quickly find other lights, apply them quickly in Climate Studio, and adjust our results.